law of sines, take two. I wasn't too happy with my performance yesterday in the video. I rewatched it and I didn't think it was very clear, so I'm going to try again today. Above the line is law of sines. It gives you a triangle that's not a right triangle. All right, this is the first time we're doing trigonometry with triangles that are not right triangles. So far, SOHCAHTOA, everything we've done was with a right triangle. So since it's not a right triangle, it's a little bit different. It's this formula right here: sine over A equals sine over B equals sine over C. So review from yesterday: the capital letters are your angles, the lowercase letters are your sides directly across from the angle. So little a is straight across from angle A, little b is across from angle B, and little c is across from angle C. Now, why did I write all this on here? All this is trying to make sense of the law of sines. This right here with the two equal signs in it. When you go to solve for an angle or a side in these problems, you're not going to use all three of these at the same time. You're never going to have two equal signs in your problem. You're only going to have one. So you're either going to use A's and B's, or you're going to use B's and C's, or you're going to use A's and C's. You're never going to use all three of them. So you've got one of those three combinations that you're going to use. You got to pick the one where you've got 3 out of the 4 places with numbers. All right, so you got to have at least 2 sides in an angle or 2 angles in a side. All right, this side over here is the exact same thing as these. I just flipped them. It's the reciprocals, and that's what this is. This is just a review to show you that reciprocals are equal to each other. If 3/4 is equal to 3/4, and you flip them both, then 4/3 is equal to 4/3. So that's all I've done here is flip my law of sines. Why do I even need to do that? Because if you're trying to solve for a missing side, you want say you're trying to solve for side A and you've got all 3 of these as numbers. You want side A to be in the numerator. Remember, when you're solving for x, you want to know what x equals at the end, not what 1 over x equals. So if the variable that you're trying to solve for is in the denominator, you need to get it into the numerator. So you might as well just start the problem with it in the numerator. So if you're missing a side, start with one of these 3. If you're missing an angle, start with one of these 3. And then it's just algebra. Then it's just isolating the variable and using your calculator. So here's an example from yesterday's work. This is B, 1B. All right. All 4 of these yesterday were like this, where they gave you 2 of the angles and 1 of the sides. So you didn't even have to use law of sines to solve for the angles, because angle sum theorem, if you have 2 out of the 3, you know they add up to 180. You can figure out the third. So the third in this one would be 39 degrees. All right, so there, you've got all 3 of your angles. That should be pretty easy in all 4 from yesterday. It's getting those other 2 sides that was the difficult part, especially because I didn't tell you the little trick of starting with the sides in the numerator. So now that I've told you that, maybe it'll be a little bit easier moving forward. So I'm just going to pick side B. Let's solve for side B first. So I'm going to put side B in the numerator. Let's see here. I already did the work. I want to make sure that I did this. Yeah. Okay, good. So side B is in the numerator, and then I'll use C, because you have to use C here. You've got to use your other fraction. You've got to have numbers for both the side and the angle, and the only ones we have that for are C. We don't know side A, so we can't use 39 degrees and another variable A. If we have A and B and we don't know what either one of them are, we're not going to be able to solve for them. That's the thing about algebra. You can only solve for one variable at a time, unless you have systems of equations, which we're not doing that here. All right, so it's 23 over sine of 59. So now it's just algebra. Now it's just solving for B, getting little b all by itself. Well, it's almost all by itself. It just has a denominator. And how do you get rid of a denominator? You multiply it to the other side, and it goes into the numerator. All right, so I'll multiply the sine of B to the other side, and then I'll put it in the numerator, because that's where denominators go when you multiply them to the other side, is into the numerator. So that's your second line. And B, I might as well substitute in the number for B. That's 82 degrees. All right, so I substituted in for my angles, and I multiply the denominator to the other side. Now we know what B is. It's 23 times the sine of 82 divided by the sine of 59. Well, sine, cosine, tangent, are just decimals. If you plug in sine of 82 into your calculator, you get 0.99. So we end up with b is equal to 23 times 0.99 divided by sine of 59, and if you plug sine of 59 into your calculator, you get 0.85. Now I will multiply the two numbers that are in my numerator, 23 times 0.99, and I get 22.77. You get a lot more numbers after your decimal, but I'm just using 2. Divided by 0.85, and then when you do that math in your calculator, 22.77 divided by 0.85, you get 26.79. So that was the answer for B, 26.79, whatever it was, centimeters or inches. I didn't write down the units. All right, now we just have A to solve for. So A, I'm going to use C again. So I'm going to have 23 over sine of 59, and then this will be A, and this will be A, and sine of A is going to get multiplied to the other side, but A was 39. So it's 23 times sine of 39 divided by 59, and when you plug in sine of 39, you multiply it by 23 and then divide by 0.85, you get 17.02. So from here, it's the exact same thing that we just did. We're just using sine of 39, so it's not 0.99 anymore. It's not 22.77. But you guys can figure that out on your own now that I've shown you the one example, and I told you the answer is 17.02. Now, one thing I want you to notice about this triangle, and so you can kind of check your work, or at least you could check for red flags, see if you did something way off. Whatever angle is the biggest has the biggest side across from it. So out of these three angles, 82 was the biggest. 82 is bigger than 59, and then 39 was the smallest. So that means the side across from 82 has to be your biggest side, and it is. 26 is our biggest number. And then the side across from 59 has to be the second biggest, 23 it is, and the side across from 39 has to be the smallest, and it is 17.02. So that's something that you can look at as you're solving these to make sure that you didn't do something wrong. If you would have got something smaller than 23 for B, you should know right away that that's wrong, because 82 is bigger than 59, therefore this side has to be bigger than 23. So that's a little trick to look for. It doesn't necessarily tell you what the right answer is. You could just know that if you did something wrong, it might set off a red flag for you. Say, oh, there's no way B can be less than 23 here. So it's something to keep an eye out for. All right, that should hopefully, between those two lessons, start to sink in a little bit. I think you'll be able to do the 4 problems for today.